Think about this for a second. When you pick up a warm cup of coffee, you feel everything all at once, right? The shape, the weight, the heat. It's just one single perfect moment of touch. But what if I told you that your brain is actually a time-traveling supercomputer, pulling off an incredible trick to make you feel that? We're going to dive into how that internal time machine really works. Because here's the thing. Some really fascinating new research shows that the different parts of a single touch, like the pressure from your fingers and the warmth from the cup, are actually hitting your brain at totally different times. So it raises this huge question. If that's true, how do we experience everything as happening right now? Okay, so to get this, we have to understand what touch really is. And it's not just one thing. It's more like a team of different senses all working together. You've got mechanical sensors that feel pressure and texture, and then you have thermal sensors just for temperature. Your brain is the one that takes all these different signals and weaves them together to build this rich, detailed picture of the world you're interacting with. And this is where it gets really weird. There is a massive speed difference in this race to the brain. Pure touch, the feeling of pressure, is the sprinter. It gets to the brain in as little as 20 milliseconds. But cold signals? Much slower. And warmth? Well, warmth is the slowest of them all, taking more than a quarter of a second to arrive. So it's like a race where the runners all start at the same time but finish ridiculously far apart. How on earth does the brain call that a photo finish? Now, this whole brain puzzle isn't just some fun science fact. It's actually a huge roadblock for technology. For virtual reality to feel truly real, truly immersive, it has to be able to fool our sense of touch. But if our own brains are doing all this complicated time editing behind the scenes, how can we ever build technology that gets it right? Well, the tech that's trying to solve this is called a cutaneous display. You can basically think of it as a screen for your skin. It uses all these tiny devices to create sensations of pressure, vibration, and temperature, and the whole goal is to make a virtual object feel completely real. And this gets to the core of the problem. If you send a physical pulse and a warm sensation to the skin at the exact same physical moment, it feels wrong. It's totally unnatural. In fact, the super fast pulse signal can even mask, or basically just erase, the slower warmth signal. The illusion is totally shattered, and you're immediately reminded you're just in a simulation. So, a team of researchers decided, okay, we're going to crack this code. They designed this really clever experiment to figure out the brain's secret formula for time. Just how much of a delay do you need for different feelings to seem like they're happening at the exact same moment? The experiment itself was actually brilliantly simple. A person would put their hand on a device that could make a warm sensation and a physical tap. The device would trigger these two things at slightly different times, and all the person had to do was answer one simple question. Did they happen at the same time? That's it. And by doing this hundreds of times with all sorts of different delays, the researchers could literally map out the brain's secret rules for perceiving now. What they were really looking for is something called the simultaneity window, and you can think of it like a margin of error. It's that little slice of time where your brain is willing to just go, close enough, and it merges two totally separate events into one single unified experience. And honestly, what they found is just mind-bending. It turns out our brain isn't just sitting there passively getting information. Oh no. It is actively editing our timeline of reality to make it all make sense. This quote from the research paper really gets to the heart of it. We go through our entire lives completely unaware that our brain is constantly, actively compensating for these huge processing delays. It's like a built-in special effect that just keeps our world feeling smooth and immediate. So check this out. This is the magic number. To make a warm sensation and a physical touch feel like they happened at the exact same time, the warmth has to start a staggering 569 milliseconds, that's more than a half a second, before the touch. Your brain gives that slow-moving warmth signal a massive head start, so it can cross the finish line at the same time as the much faster touch signal. And this chart just shows it so clearly. For cold, which is a little bit faster than warmth, the brain only needs to give it about a 245 millisecond head start. But for that really slow warmth signal, it needs more than double that time. I mean, your brain is basically a stage manager, telling different actors when to walk on stage so they all show up for the big final scene together. It's amazing. And there's another fascinating detail here. This chart shows that the window for warmth is way wider than it is for cold. We're talking over a full second. That means our brain is just way less picky about the timing of warmth. It's more willing to accept a much bigger range of delays and still say, yep, that happened at the same time. It's almost like our perception of warmth is a little bit blurrier in time.
So what does this all mean? I mean, beyond being a really cool piece of neuroscience, why does this actually matter? Well, it has some pretty profound implications for how we're going to interact with technology in the future.
What this research really is a recipe book for reality. For the very first time, developers who are making VR or other haptic technologies, they have the exact numbers they need. They don't have to guess anymore. They can literally program their devices to give warmth a 569 millisecond head start, perfectly copying the brain's own magic trick. And the applications for this are huge. We're talking about virtual reality where you can actually feel the warmth of a digital fireplace or the cool touch of a virtual metal tool. It could totally change remote communication, maybe letting you feel the warmth of a loved one's hand through a device. It can even help reduce cybersickness, which is often caused by that weird mismatch between what our eyes see and what our bodies feel. And that leaves us with one last really big thought. This research isn't just about making better video games. It's about blurring the line between what's physical and what's digital. By cracking the code of our own perception, we're literally learning how to build new worlds that are, to our brains, completely indistinguishable from reality. And we really have to start asking ourselves, what is that future going to feel like?